Hey everybody. This is lesson 7, and to quote Kevin McAllister of Home Alone, this is it. Don't get scared now. Okay, he says that at the end of the movie before the burglars break into his house. You've learned a lot of rules, and now in this unit, this lesson, you got to use all of them at once. Okay, and it can get a little scary. So let's take a look at these. Okay, here's an example that I'm going to use two rules. Okay, does it matter which one I use first? Not really, but I'll tell you. I think it tends to be easier if you can to use them kind of a little bit in the order you learned them, I guess. I always try to use the product and the quotient rules first if I can, but only if I can. Okay, in this case I can. I've got the same base. I'm multiplying, so I'm going to add the exponents. Let's see, 9 plus negative 11 is going to be negative 2. Okay, now I'm just going to use that negative integer exponent rule down here and say this is 1 over 3 to the second power. Okay, sometimes they want it just like this. Sometimes they want you to turn it into 1 over 9. Okay. So that's A. And we use two rules here. First, I use the product rule. Okay. After that, I use the negative. Sorry, that's my dog. He wants me to feed him, but it's not time yet. Negative integer rule of exponents. Okay. And you guys, this chart, I've been attaching this chart. Miss Angel gave it to me. I've been attaching it to the lesson notes. If you can't find it, just webmail me and I'll just send it to you in webmail. Okay, but I'm gonna do the next one. Okay, remember, don't get scared now. This one looks terrible. This next one, just look at it. Okay, this is it right here. Negative 5 raised to the negative second power times 10 to the 0th power over 6 to the negative 4th power. All right, I'm gonna have to erase question A. All right, let's do this. Okay, I'm going to highlight a couple of things I'm noticing here. You guys, I noticed that right away. I love the 0th power. Okay, that's just going to be a 1. I'm going to do that right away. Okay, the other thing I noticed is we have negative exponents that are in a fraction. Okay, and what this means, because of it makes it into a reciprocal fraction. Okay, if it's already in a fraction, it's going to move it. I used to call this the upstairs downstairs rule. So basically, the one in the bottom is going to move to the numerator. The one in the numerator is going to move to the denominator. So that's just a little preview of what's going to happen here. Okay, that negative in front of the 5, that's just part of the base. Okay, so we can almost kind of ignore it. All right, here we go. Negative 5 to the negative second power times 1. I'm just going to do that one right off the bat. 10 to the 0th power is 1. This is going to be over 6 to the negative 4th power. Okay, so this was the 0 power rule. All right, now I'm going to use the negative integer rule of exponents. Okay, and so you can kind of see it right here. If it's in the bottom of the fraction, it moves to the top of the fraction. Okay, if there's nothing in the bottom, you can put it over 1, just like 2 is 2 over 1. Okay, but so what's going to happen here? This is what it's going to look like. The 6 to the negative 4th power, that's going to come up top, and the power is going to become positive. Once you move it, the power becomes positive because you did the thing. Okay? The negative exponent is what's moving it. Once you move it, exponent's not negative anymore because you did the thing. It's done. Okay, -5 to the negative second, that's going to move down here. And it's going to end up looking like this. -5 to the positive second power. Okay? At this stage, I've got all positive exponents, and I've done all the rules I can. Okay, this is in simplest form. That said, they might want it like this. Okay, they might want you instead to actually figure out what 6 to the fourth power is. And then -5 to the second power, this is actually going to become positive because it's a negative times a negative. Okay, if the negative's in parentheses, it's part of the base and it gets multiplied. I don't know what 6 times 6 times 6 times 6 is. I'm going to use the calculator for that. But I know -5 times -5 is positive 25. So here I can just do 6 times 6 times 6 times 6. And I get this big number, 1,296. Okay. Or, see, I'm in the standard calculator. If I click these three lines here, I can go scientific with my calculator. And I can type 6, and then I'm going to hit this little X with the little Y button, and I'm going to raise it to the power of 4. Same answer. Okay. So 1,256 over 25. This could be the answer they're looking for. And gosh, maybe they want that as a mixed number. I don't know. It's ugly enough the way it is. All right. So that's that one. And then just a reminder here, let me just highlight it. What happened here, the negative exponent sent this whole thing down to the denominator. And then this negative exponent sent this whole thing up to the numerator. And the times 1, I just didn't write because we don't have to say times 1, okay? I don't say I have 2 times 1 pairs of socks. I just say I have 2 pairs of socks. Okay. All right, let's do this last one. I'm sorry these are so hard, you guys, but it's good for you. You can do hard things. You just need to have support, okay? So watching this video is you engaging with some support that I'm offering, and using this sheet that I've been posting. That's some more support that you're utilizing here. Okay, so this last one, I'm not seeing anything friendly about this. All right. 7 to the first times 5 to the third. I can't use the product rule because they don't have the same base. I've got a base of 7 in the first one. I've got a base of 5 in the second one. 7 squared times 5 to the negative first power. All of that's getting raised to the negative second power. All right. And then I just realized I forgot something. There is a negative in front of this. It's 7 to the negative first power. So let's kind of use this upstairs downstairs thing. This is going to move downstairs. Once I do it, the power will become positive. This whole thing is moving on upstairs. All right. So here we go. If I do that move, this is because of the negative integer rule. Then I have 5 to the third in the numerator, and then parentheses 7 to the second times 5 to the negative first to the positive second power. That's going to be over 7 to the first power. All right, the next rule I'm going to use is the power rule of exponents. Okay, and so I'm going to highlight where that's going to be before I do it. So see, here's the power, And this power is going to multiply both of these exponents, the 2 and the -1. Okay, so let me shift up here and get a little more space. Okay, but basically I'm going to, why can't I do this? Here we go. Okay, I'm going to move this down a little bit. Some more space here. If you're not doing these on paper, you should be. Oh my goodness, look how much work these are. All right, so basically, okay, the 5 to the third and the 7 to the first power aren't going to change. But check out what I'm going to be doing here. It's going to be 7 to the 2 times 2 power, okay, times 5 to the -1 times 2 power. All right. Okay. So, and then here, the 5 to the third right next to the parenthesis, that means times. Okay. So I'm going to put a little multiplication symbol there. All right. And then let's go ahead and do that multiplication. So 2 times 2 will be 4, and -2 times 2 will be -2. That Okay. And then let me write what rule that was. This was the power of a power rule. Okay, so now I have 5 to the third times 7 to the fourth. Oops, that doesn't look like an exponent. Let me just rewrite that. I don't want to think it's a 74. Times 5 to the -2nd power over 7 to the first power. Okay, and I'm going to go ahead and use the negative rule again, like I did way up in the first step. I'm going to use the same color. Okay, here it is, negative exponent in a fraction. This is the upstairs downstairs thing. Okay, and it's on the rule sheet right here. Okay, see the negatives in the bottom of the fraction, and then it goes to the top, and then they write it as a whole number. Okay. All right, so now our fraction becomes, if that guy moves down there, it becomes 5 to the third times 7 to the fourth over 5 to the second power times 7 to the first power. See how I actually wrote the thing I moved down? I moved it down and I actually wrote it first. That's because of the next rule I'm going to use. Okay, so I did that for a reason. This was the negative integer exponent rule. All right. Now I'm going to use the quotient rule. Okay. Almost done. This is the last one. So if you look here, I have the same base of 5 in the top and the bottom of the fraction. I have the same base of 7 in the numerator and denominator of the fraction. That means I can use the quotient rule. So this, you've got to go in the Wayback Machine, because this was in like lesson 3, I think. Lesson 3. If you have the same base and you're dividing, fractions mean division, you can subtract the exponent. So 5 to the 3 minus 2, and then 7 to the 4 minus 1. Final answer, 5 to the first times 7 to the third power. Okay, fully simplified, All the exponents are positive. There aren't any more rules I can use. So now I'm done. But yikes, look at this problem. This was ugly. 5 to the first times 7 to the third. And a lot of times they'll just write 5 times 7 to the third power. All right, so let's check out all the things we did here. Okay, the first thing we did in the problem was we moved stuff around based on the negative exponent. Okay, after that, we had a power raised to a power. Okay, we had this whole thing in parentheses, 7 to the second power, 5 to the negative first, and we had to apply that power of 2, okay, to both of those. I'm just going to take the highlighting off because it looks a little hard to read. Okay, and so basically the exponent on the outside you need to multiply. It kind of distributes in a weird way. Okay, it's kind of like the distributive property. So we multiplied it through. We ended up with 7 to the fourth power, 5 to the negative second power because it was negative 1 times 2. Okay, that was power of power rule. Then we use the negative exponent rule again. Okay, and then we could use the quotient rule to get our final answer. Did you get scared? It's a little scary, but it'll be okay. Okay, this video's gotten a little long, so I'm gonna wish you good luck and spend time on these. Okay, they're harder. All right. I don't know if you need anything.